Hi folks, let us take a diversion today and instead of doing the lead code's typical problems that are good for the practicing of algorithms and things that sound very interview type, let us do something today which is more related to the real software development. And what we are going to do is we would take a look at some of the things that we run across in embedded systems. And when you are trying to do code for embedded systems, you have things like many different features. So if you're doing feature development, you tend to get into what is known as spaghetti code. Now, I know some of you probably love spaghetti, and there's nothing wrong with that. I love it myself. But spaghetti code is something that is usually very hard to maintain, and it becomes kind of a messy in the end. And just like spaghetti can be messy too. So if that is the case, then what are the alternative approaches to software development if you do not want to have spaghetti code? So you have a module, you may have a module, some module, whatever, and let's say this module has, your module has tons of features. And these features usually, the way it works is every module you have you will have init initialization code, I hope I'm spelling it right, but basically init code, and you will have a mostly the apply or I would say the main processing kind of code, and then you will have a cleanup code. And these things will be happening at the module level in your spaghetti code. Now your spaghetti code is doing all this, and every time it does this, it sees, oh, is this feature 1? So you might be having lots of if then else. You might say, oh, is this feature 1? We need to do this extra special initialization. If it is feature 2, so you may have code that may look like if. So suppose this is your module in it, and it may have some void star data, whatever the heck it is. And here you might say you might say things like if feature, so maybe there might be generic in it in the beginning, and then you might say if feature 1 do this feature, there might be some feature 1 specific code. Initialization code, right? And similarly, you might have other if then else statement, else if feature 2, you may have some code which is specific to feature 2, specific code. So now if that is the case, and so on and so forth, right? Now This kind of programming is, and similarly you may have this all this is so similarly you may have code which is like module apply code, then you may have a module cleanup code, and each of those things you may be doing things like writing this spaghetti style code with if feature 1 else if feature 2 blah blah blah, and sooner or later you find out that your code is unmaintainable. It's hard to even look at it because your mind hurts just like looking at it. So what do then? You basically decide to refactor your code, and what is refactoring in this case is we will use a new approach known as function vector approach for this kind of code, and let's see what that is. So let's rename our file. We're going to call it function vector demo, and let's see how it works. So here we are. I'm going to comment all this out because there's no way it's going to ever be compiling this kind of thing. And so let's start. How are we going to do this function vector approach? So instead of having these global variables like module init and globally working on a module level, let's try to apply these features in the very beginning. Decide on what features or what feature are we going to be applying in this case, and then choose the appropriate set of functionality. And when I say that, how are we going to do that in C programming language? So what we can do is we can start with something like start by defining our I would say some kind of a uh, in C language we will call them function pointers, but basically they are your features, or I would say not features, but the things that your module does when a certain feature is applied, or the processing that your module needs to do. So let us say you have a function pointer. So think in terms of function pointers and function vectors. So let's start by defining these function pointers. So that is so you will have init for for all the features. We have the same things happening, which is that on a higher level, which is that you need to do a initialization, you need to do some applying some or do some processing. I could have also called it process or apply, and then there is a cleanup code. So these are our function pointers. Now we'll have to, let's say we had certain features, and feature 1, feature 2, feature n. So 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 before I go to the feature, let's see. So now we have these function pointers. We have to come up with a thing known as function vector. So the function vector is nothing but a set of these functions. And how do we do that in C language? We provide a struct to basically group items, related items. We say type def function vector, and then we say the members here would be init, apply. We can use our new type defs right there, and then we will have cleanup. Right. So that is going to be our function vector, and let's define this new type. Call this new type a function vector type. So the way our approach is going to be, we will apply this set of operations, we can also call them operations, on a typical feature or any feature that basically is module needs to basically process. And so let's have a type def which defines the uh, which will have a list of different features that this module can have. So we can say feature list, type def enum feature list, and that is, suppose you have feature 1, and then we have feature 2, and then usually, it's good to have, you can have as many features as you want, but I'm right now, for the sake of example, just leaving at 2. And then we will have another enum which is just says that this is the end, and this can be good for checking error conditions when your code needs to basically return a feature type, and if you see that it is none of these, then you can return. If it doesn't apply to any of the features, or if the parameters passed are wrong, then we can simply return feature list end. So, and that's, let's call that as feature list enum. So if that, so now how are we going to do this? We will have to start defining our feature 1 init feature, and then for each feature we will have, for example, we can say feature 1 init, and it takes some void star data, and all it says is, it says called or whatever. I'm just putting these debug statements for now. Later on you can basically have the real code in your application, but right now I'm just going to do. And by the way, this is just a macro that this is a very handy thing to, rather than saying the feature 1 and it called, let the preprocessor or the compiler do the job for you. So similarly, you would have feature 1 apply, right? And then you will have feature 1 cleanup. So this is the, for each feature. Now you see what happened. Instead of doing the spaghetti in the each and every place, having to check if it's feature 1, feature 2, we have basically completely cleaned up the code, in the sense we have taken the at a very higher level, we have decided what feature 1 initialization requires us to do, and we have basically put all that in separate functions. Similarly, for feature 2, you may have to write these init, apply, and cleanup things, and we can do that right now. So these are the, at a very higher level. You start looking at your code and you start understanding more what are these different features mean in terms of init, apply, and cleanup for us. So once you have that, then what we do is we start by defining. Now you see, when I said here function vector, so now we need to do a callback table. So let me write here. Let us define a callback table of function vectors for each feature. And that would be callback table. And then in this, the callback table is basically nothing but array of these function vectors, and we can even initialize it in the very beginning. we can say that for example, we can say here feature 1 in it, and then feature 1 apply, and then we can say feature 1 cleanup. And once you have that, then by the way, the last member of the structure initialization may skip comma, but I'm still actually keeping that. So that's your member 1. Now another member is going to be, for example, similarly, we will call it feature 2 in it, feature 2 apply, and feature 2 cleanup. Now, so that is here. So we have initialized our function vector callback table, and then what would happen in a typical case is you would decide in your top level module, you will decide what feature we will have, and then you will return the appropriate function vector from this function vector callback table. So let's write a little uh, dummy function which will basically just return for right now some feature that we can ask the user in this case actually, but in reality this will be probably some module specific data that would return a feature, or you would know what feature it is. But here, since we are trying to do some kind of a simulation code, uh, then we can simply, for the purpose of testing our code, we can have a um, little dummy function which will give us some feature that we can apply here. So, so in this case, this is a very simple function, get feature, and then the get feature basically gives us a feature that we can return to our caller. And here we'll just ask the user, hey, just what feature you want. So this is kind of a little dummy function that you probably have to expand in your real code. In your real code, this might be, for example, just to give an example, get feature might take parameters like imagine if it was cars, it was about cars, and you had to like decide if this car needs AC, and or if this car is without air conditioning, or does it have GPS facility, or does it have what kind of paint, what kind of wheels, what kind of engine, and things like that. So all these module specific stuff will be basically going here. Now at this point, let's write our get function vector, which will return a func vector pointer to function vector. So we'll write that as, and we'll call the get func vector. And here again, you may have to write your module specific data here, right? You may have to pass, I'm just going to write here in commented out code, pass module specific data here. Now, here, what is the first thing we do? We say, okay, we have, okay, tell me, give me the feature. So basically, we decide on what feature we are going to apply. And usually, you may have to decide that this feature type here. And then you decide that at very top level, and basically try to partition or try to write your code in such a way that these feature types can be mutually exclusive, if that is what you think that is the way to go for your module. And for a given type of feature, you only need one set of function pointers. So that is very important here, and that is the whole idea of our code factoring instead of writing spaghetti if then else code. So let's return that. Uh, so from module specific data, we're writing here from module get feature type equal to get feature. Right now we just wrote a dummy function which will just give us some feature. So now after we have the feature, we can do a little error checking. We say feature type equal to feature list and then we have a problem, right? And then we can say, hey, return null. Otherwise we just return one of the function vector from the function vector callback table. So that's your feature type. You index in your function vector callback table by the feature type, and you return one function vector, which is nothing but a structure of function pointers. So that gives you the function vector to apply in your feature, and then all you need to do is there might be let us say a user event, and that user event would be where everything basically triggers from there. It could be a user applying certain thing on your system, and that triggers this your module basically. So the user might be saying, okay, let's turn on the ignition, and that turning on the ignition might trigger the code in your feature in your module, and then all this gets triggered from there. You deciding what feature to apply, you choosing on appropriate function vector from the function vector callback table, and then basically applying all those functions. So 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 that's the approach here. So we can have a pointer, local pointer, func vector type, which is star ft, and then ft will be equal to get func vector, and then you say here get func vector again will be based on the module specific data, right? And that is pretty much the approach here. So you get the function vector here, and with that, let me just so once you get this module specific data here, you get a function vector from your function vector callback table, and then you see then we have a big problem. We can simply say invalid feature, right? If you get function vector returns a null, then we can say invalid feature, and we can exit. In our case we have to exit, or probably just introduce some kind of error condition. Else we say else we are good to go. We can simply apply all the features right there. Basically we can apply all the features specific init apply and clean up functions right then and there. So that is apply, and then cleanup. So that's pretty much the idea here, and you can even pass some more some private data, opaque data to these things, which they may be using to basically decide on what to do in each of the init apply and cleanup. So once you have it, you're pretty much done, I would say. So let's try to exercise our code by writing a little driver kind of thing which drives it. So let's say a user event happens in your main here, and that kind of triggers the whole application of all this code. So let us try to run this. What happens? So we have a problem. Say line 78, we have a problem. So he's saying int get feature dummy function expected before int get feature. Okay, so that can be fixed because we forgot to put a semicolon after the definition of our structure declaration. Okay, so that one of now we have problem on line 92. 92 here. So feature list. I think the problem here was small and we have it wrong. Okay. Now we have a problem on line 95. And we're saying, okay, function address of func error undeclared. Func vector cb table cb underscore table. Func vector function vector. I see. So I think, oh, I see. We had actually defined that to be function vector CB table, not func CB table. So that can be easily fixed. Now let's say on line 101, we have an issue where we are saying function vector type. Okay, so this is function vector, not func. And now we have, okay, so apparently it has compiled, and let's try to change here in the standard input because we have two features and they index from 0 to 1. So let's try to run again. He's saying feature 1 init called. So when we give an input of 0, this is basically feature 1 for us because the function only takes two numbers here. It says feature 1 init called, feature 1 apply called, feature 1 cleanup called. If you give 1 and then run code, it's a feature 2 init called, feature 2 apply called, feature 2 cleanup called. So there you have it, a very modular, very clean refactoring, or I would say function vector kind of approach for your module. And these things are usually seen in embedded systems as well as in other code. So this is not really specific to embedded systems. It might be applicable in many scenarios where you had to do a lot of spaghetti if then else statements for different kind of features. So it's really helpful to think of these things at a higher level and then use a more modular approach where you basically decide in the very beginning what features to apply or what feature this particular um, application of uh, this which function pointers we can apply based on the or which function vector we can apply from our callback table based on the feature that we decide at a very top level. And even if these features that we decide the top levels are not mutually exclusive, we can always apply these function from our callback table. You could potentially, if you decide, for example, if you are here ft init, if you say get func vector, and imagine you could decide, you can call it again, maybe on some based on some other parameters, and it gives you a different function, and you can probably apply them as well. So it becomes very clean, and I think this is the kind of thing that we do not get to do on lead codes algorithmic problems. So I'm glad I got a chance to talk about it. I hope it was useful, and in the future we'll keep bringing these interesting application oriented from the real field, as opposed to academic type of problems that usually these algorithmic questions entail. So so this is a real world application of the code, and I've seen this happening a lot in the industry, these kind of requirements popping up. So I hope it was useful. Please feel free to comment on the in the comment section, and subscribe to the channel if you think this is really useful. And please let me know if you need any similar videos, or any kind of if you need any kind of clarification in your understanding of something. I would be more than happy to talk about it. I will see you guys in the next video. Take care. Bye bye.